money, properties, and all those things. Like the Bible said, naked we came, and it is very painful, very, very painful. But sometimes there's nothing you can do about it. But once we have life, let us continue to give thanks to God and pray that He Himself will still open another door or several doors through which we can still get whatever we have lost. But what matters most is that we are alive. And once we are alive, there is hope that we'll get more than what we have lost. And this also should be, should I say, a warning or a sign of being attentive. Sometimes, let me say that those who are living in the flooding areas, there are some of you, or you could hear some people who said, I've been here for 10 years, 15 years, the place has not flooded before. So some of these things you can't predict. We can't predict. But those of you who have been experiencing this, so when you see, know your place has been flooded, once the rain starts, please find a safety place, a hideout, get a better place to hide. If you're hiding somewhere and then the rain is not heavy, then the place doesn't flood, you come back home. Rather than thinking, oh, it's not going to rain for that long. And for all you know, all of a sudden you get trapped. So let's try so well to keep safe. All right. And I will also say this. We know a lot of people have lost their life. They didn't plan for it. Some were sleeping before they realized the whole place was flooded, and then they were trapped. They could not get up. Others were also trying to escape, and unfortunately, they got trapped. So this tells us that every day, every moment, every minute that passes by, we should be ready. As the Bible said, for it is appointed for a man to die once, and after that judgment. And you don't know when. You don't know when that death will come. Someone was with the children, all of a sudden the person died. Some, the children died. Others, the husband will die. Somebody, the mother. So it's something we can't predict. So if you have a day and you are alive, you give thanks to God and you make sure that you set your path straight. So if it happens that the next moment did not meet you, you know where your soul or your spirit will go at the end of this world. Because no matter what, whether we believe or we don't believe, we will die. And after death, there will be judgment. So may God help us, strengthen us, especially those who are affected. May God strengthen you. Because I can imagine the emotional trauma. If not because of time, I would have loved that you share some of the experiences with us. All of a sudden, the room is flooded. The water is climbing up to your knee, to your waist, to your neck. What is the experience? All this emotional trauma. Let go. Let's pray that God will help us to overcome it so that we can still continue with life peacefully. May the Lord. I believe you can hear me.
Yes, please.
Yes, madam. Madam.
Okay.
Madam.
Yes, dear.
Please, what about you?
Oh, by God's grace, actually, my place, when it rains, the rain passes here. It passes through my house. Initially, it wasn't like that, but when it's a new place, when people started developing here and there, There was a heavy downpour, and before I realized, my whole house was flooded, and I was wondering how. So I checked and I realized it had broken my wall. So the wall broke, that is from the back. So the whole place was just flooding, flooding, flooding. Then God helped me, and then the front side also broke, so it was able to pass away. So since then, I've not even erected the walls again, because if the problem is not solved from the back, we can't work on the walls. But for this Sunday's own, the current one that flooded so much, in my area, it didn't even rain. I am at on Dodowa Road. I'm here, somewhere. So it didn't rain at my end. So I was wondering. So it was around 10 a.m. when my daughter called me from school. She's at KNUST. So she called that, Mommy, this is the news that I'm hearing. I want to see whether you are safe. And I said, Really? It's not raining in Accra. I said, No, they say it's raining even up to Medina. So now people started calling me here and there because especially those who knew I was affected the previous time, people were calling. But thank God for this particular one, it didn't rain at my end. If it had rained heavily, in fact, I wouldn't know what would have happened. And sometimes you see, if you are renting an apartment, you can decide, okay, let me move from here to get a better place. But this is your own apartment. Where do you move to? So we just pray to God for mercy, that He always have mercy on us. So Sairam, for this particular one, by the grace of God, I was safe because it didn't rain here.
Good to hear. We thank God.
Yeah. All right. So now let's do HCI. So before we start today's session, can we please revise on what we did last week? So please tell us what you remember from what we did last week. And then how you are applying it to your day-to-day activities, especially when we are with computing devices. How do you understand things? How are you is it having any influence in the way you see computer devices, the way you work with computer devices now? Yeah, so let's use some 5 minutes to do this discussion, then we proceed. Please, we are revising what we did last week. So what do we remember from last week's session? And then how is it influencing our day-to-day activity, especially when it comes to the usage of computing devices? Oh, hello, are you with me?
Yes, please. We are with you.
Oh, so please, let's interact. Or you don't remember anything?
Hello, madam.
Please,
Yes.
So me from last week, what I remember is that I'm talking with regards to like human being that we process information by hearing, and when you hear it, we use the brain. The brain serves as like the CPU that helps us to process information. So from last, that's what I remember.
Okay, so how is it influencing your day-to-day activity, especially relating to computing devices?
So I think from last week I realized that whatever thing we hear, whatever what data that we hear, we process it to make meaning out of it. So maybe if you're having a conversation with someone and someone says something, your brain has to think through before you're able to understand what is happening. Or maybe if you like in a new language, and you are learning a new language, your brain is not known to that particular thing unless you keep learning it to understand the pattern, and that one you'll be able to make meaning out of it when you see it somewhere. So same way like the computer also processes. So whatever information we give the computer, it also like processes before it becomes like a meaningful information to us.
All right, thank you so much. Thank you. Yes, any other person? Especially for those of us who were not affected by the flood. Those who were affected, in fact, the emotional trauma that they've gone through, some of them have not yet recovered. So they can't remember. They can hardly remember whatever we've learned so far. So those who were not affected, please, let's try to say something so they can, to see if they can recall, what they've learned. Sairam.
Madam.
You know, I always mention your name.
Yes. Okay, madam, please, last week, we also learned about please, just a minute.
Okay. So can someone take over as we wait for Sairam to prepare her thoughts well? Stephen, you are the constraint, but you don't want to communicate. So tell us. Stephen, are you there? Stephen, are someone? All right. So no one apart from who even spoke. I didn't get the name. Apart from him, no one remembers whatever we did last week. Please, can you hear me or you can't hear me?
I can hear you.
All right. If you can hear me and you just don't want to talk, it's okay. I think we can move on.
Hello, madam.
Yes, Aaron.
Please, sorry. Okay, so last week, I also recall on the physical receptions and then how images are focused upside down on the retina, and then you also gave an example of like the questions you asked on how how smart a human being is, and then with a human being and a computer, who is more smarter and
Intelligence.
Intelligence, yeah.
Intelligence is different from smart. So we have intelligence and then we have powerful.
Yeah. So, and then there was an example you gave about the screen, how you gave that the way we are used to the screen now and how it will affect us maybe in the future, instead of getting too much addicted to the screen or to the screen, we should rather, especially with the infants, so that whilst growing, it doesn't affect them too much. Then the vision.
Yes, continue. Sorry.
You spoke about the vision, how we process information as human. and how each person is also different. And then with the vision, you spoke about you spoke about interpretation, how we process interpretation also.
All right.
Yeah.
Okay. Thank you so much, Kairan.
You're
So at
welcome.
least I've gotten 2 out of 14. That is okay. But colleagues,
Madam,
let me. Yes.
we talked about how the human being uses the memory, its memory to, like, the memory was in 3 stages. So you give an example as you said, when a guy sees a woman and he watches the first time, it saves into the sensory memory. And when she goes and the guy recalls, that data is saved in the short-term memory. And after a long time, and the guy tries to, like, remembers, recall it, that it saves into the long-term memory.
All right.
Hello,
Andrews,
madam.
are you done? Yes, Andrews, are you done?
Yes, madam.
All right. Thank you. Do you know why I'm laughing? I'm laughing because I gave 2 different examples on that scene. And one was about the lady thing or the woman thing. So I don't
Madam,
know why you remembered the woman example and you didn't remember the course material example.
Madam, please, your line keeps breaking.
All right, so that's fine. Okay, thank you. So I think we can move on. But before we move on, I wanted to say something. You see, it is very good to contribute in class. We as lecturers, sometimes you finish marking and then you look at student grades and you feel like the student to another level, especially when you
Madam,
see someone having 70.
hello, madam.
Yeah.
Please, your line keeps breaking.
Hello, Justice, we can't hear you. I don't know whether it's from my end or your end, but I can't hear
Yeah.
you.
Madam, I said your line keeps breaking.
My line is breaking. Okay.
Yeah.
It's actually raining here. It's raining small, small, so I don't know. But is it better now?
Yes, please, it's better now.
Okay. So what I was saying is that it is good to contribute in class. It is good to be very active in class because as lecturers, sometimes we finish marking scripts and you feel like the students didn't do too well. So you want to favor them. So when we are doing this, when we are favoring students, we consider, we look at the students. Who is this person? How active is the person in class? All those things count to help us add some scores. There are times that you find a student in class who is very active, punctual, regular, and contributes in class very well. But the person writes exams and he doesn't do well. Then you feel like, how? What happened? So you can favor the person, add something to it. You finish, you check your grades and someone is having 71, the person 79 or 78, the person need a mark or 2 marks to get an A. Someone is having 49, that person is failing. You need a 1 mark to pass. Now the next question is, who is that student? Do I know the person? Is the person active? So all those things help us to favor students. So don't hide behind the online, don't hide behind your cameras, and then when we call you, you refuse to talk. There was a time I was doing this thing, and then everybody was quiet. No one was responding. Now, when we ended the class, they thought I had left. And then they now started doing their own chat, and one person was like, "Hey, Obo Medina, me wo hopa o me shada they said they are maintenance. What can say? Oh yeah, me. Yeah, me na oh yeah me oh yeah oh." So let us not hide behind the cameras, and then when we call you, you refuse to speak. All right. So let's move on. Today we are looking at the interaction. Last week we looked at the human. Then I asked you to go and read on the computers. I wanted to find out what you have learned about the computers. But even the one that I taught in class, you have refused to talk. So how much more the one that I asked you to go and read? So let's move on. So we are looking at the interaction part, because human-computer interaction. So we've done the human in class. I asked you to do the computer, because that is something you have learned over and over again. So today we are looking at the interaction. So when we say interaction, what do we mean? When we say interaction, what do we mean? So we'll be looking at some few things. One is the interaction models. That's the frameworks that guide us during interaction, or that guide us in transmitting information between the user and then the systems. And then we also look at economics. When we say economics, what do we mean? And interaction styles, some styles that or some forms, some ways in which human interact with the computer. And then we also look at the context in which we interact. We pray and hope that we can finish all within the time. All right, so what is interaction? I don't know if we should still interact, or I should just go ahead and then teach and go. So when we say interaction, what is interaction? I know all of you say it's what? A communication between two people. But here, because we are relating it to a computer, so you say a communication between the human and then the system. So it is a communication between the human and the system, and also from the system to the human. So that's why we see that the arrow is bidirectional. So the human communicates to the computer. Please, I believe you can see my screen. Is my screen visible?
Yes, please.
Yes, please.
Oh, yes. Thank you. So the human communicates to the system, and the system communicates back to the human. So it's a bidirectional. And now we are asking, so is it or is that all? Just communicating? You just receive information and get a feedback? Is that all what we mean by interaction? No, of course. It is more to, or there is more to interaction than just communication or sending and receiving information. So before we start communicating or interaction, there are frameworks that help us to understand what happens. So we'll be looking at those frameworks or models. And the first one is what we call the Norman's model. The Norman's model, or the Norman's interaction framework. What is this framework saying? So it is saying that in communication, there are some three things that we need to consider. The first one is the domain, that is the area of work and study, or the area in which the communication is done, the domain in which the communication is done. If you understand that domain, then you can understand the communication or the interaction there better. For instance, let's say most of us have not used the DOS system before. So since we've not used it before, we don't understand that domain. So if we should bring you a system developed with a DOS application, it will be very difficult for you to interact because you are not conversant with that domain. So the domain is one. Then two, in every interaction or in every communication, there should be a goal that we have set to achieve. So that goal should also be there. If there is no goal, then what are you going to do? You don't want to achieve anything. So what are you going to do? Nothing. Then, now that we have the goal, then we consider the task. That is, how do we do it? How do we achieve the goal that we have set? So these are the things that we need to consider when it comes to interaction with the computer. Now, Donald Norman's model is saying that when it comes to interaction, there are 7 stages. There are 7 stages in interaction. And these stages help us to achieve whatever objective that we have. The stages is from the user to the computer or the system, and then back to the user. So starting, the first stage is that the user will have to establish the goal. So there should be a goal established by the user. Then after that, the user must formulate an intention to achieve the goal. If I have a goal and there is no intention to achieve it, the goal will still remain a goal, but I can't achieve it. When we were in primary school, there was a particular book that we read. I've forgotten the title, but there's some phrase in it which I never forget. Building castle in the air, which is also a proverb that we normally use. Building castle in the air. So you are there, oh wow, build a castle. And you don't have any intention to start building it. You are not looking for land, you are not looking for all the tools and equipment that you need. You're only using your math. So when we have the goal, we need to formulate an intention to achieve that goal. That is stage 2. Then stage 3, we have to specify the actions that we need. And those actions happen at the interface of the device or the system. Then we have to execute the action. After executing the action, then we perceive the system state. Now I have executed the action. So I'll now be observing the system and I'll perceive based on whatever feedback the system is giving, I can perceive that, oh, the system is working. It's doing my thing for me. Then stage 6, we interpret the system state. So when we perceive that the system is going to do this for me, I think this is what it will be doing. Now you interpret, okay, has it actually done it? Okay, it has done it. I believe this is what it has done. And then finally, we evaluate the state of the system with the goal that we have set. So now let's check whether the system has been able to achieve the goal that I have set. So this Norman's model, we said it concentrates on the user's view of the interface because we communicate with devices through the interface. So when I'm looking at the interface, when I execute my actions at the interface and all those things, and I receive my output still on the interface, I can now evaluate to see whether my goal has been achieved. So in this, whatever happens is treated as a loop. It's in a loop, so it's cyclical. So it's not like I've done it to the end, it's finished. If I want to continue, it continues. So first, we have the goal that is set. Then there is a system. So when we come here, there is what? An execution. Now, Norman has divided the 7 steps into what we call golf. So you have 2 golf, G-U-L-F, like the normal golf that we play. So he has divided that 7 steps into 2 golf. And he has the first one called the execution golf and the Second one is the evaluation gulf. I establish the intention to execute it. I provide my action, then I do the execution. And that is done into the system. Now I have to perceive the system states. You perceive, you interpret the system state. And finally, you do the evaluation against. First, you set the set, then you come to the execution state where you formulate your intentions. You specify the actions at the interface, then you execute. And after that, we move to the evaluation gulf. You perceive the system state, you interpret that state, and then you evaluate to see. So let's take example. Let's say I want to send an email. So Sarah, I'm sending an email to you. My objective is that I'm sending some attachment to you. So let's say a course material. I'm sending it to you. That is my goal, so that I'll send something and then you will receive it. So that is the goal. So I have to formulate the intention. Okay. Now, because I want to send an email, I need my devices and anything that will help me to do that. Then I specify the action. So the action is what? I have to open my email. I should make sure that there is internet connectivity. All this thing is on the part of the human being when the system is not involved. So when we look at this part, we are still on the part of the human being. That's the execution state. So I specify the action. Then finally, I now execute the action into the system. So executing the action is what? Okay, once I've opened my email, I will load the attachment, add some write-up, and then I send. So when I click on send, at that point that I click on send, now I have executed the action. So I've moved into the system now. So into the system, what happens? I perceive the system state. So in sending an email, an attachment, let's say at that point, when I see, how do you call it, a spin or a progress bar moving, that green thing moving, then I perceive that, okay, it appears the system is what? Sending the message. Or when I click on the send, so I perceive the system is going to send a message. So when I see that status bar moving, then I can interpret that, oh, it is actually sending the message. Now, finally, when it tells me or give me that final feedback that sends, then I can now evaluate against my goal. So how do I evaluate? Either I give a call or wait for Serum to give me a reply or response that I've received the email. So once he has received the email together with the attachment, then that means my goal has been achieved. So I have evaluated and then my goal has been achieved. Any question on this?
No,
Those
please.
who are in the good mood, to talk. Any question?
No, please. For now.
All right. Is it clear?
No, please.
Yeah.
So that is for the normal framework, that we have 7 stages when we are interacting with the computer. So the first stage is that you have to set up your goal. The second stage, formulate an intention that you want to achieve that goal. Stage 3, specify the actions that you want to take, and those actions will be taken at the interface of the device. or of the system. So you specify all the actions that you think you can take to help you do that. Then finally, now execute that action that you have specified to take, execute it. And after the execution, now you perceive the system state. Then as you watch the system, you interpret what you think the system is doing or has done. And then finally, based on the output that you receive, you evaluate to see whether your objective was achieved. Okay. So Norman is saying that some systems are harder to use than others. And it is true. So he's saying that at the gulf of execution or at the execution stage, the user's formulation of action maps to the actions that are allowed by the system. So if I have formulated an action, but the system does not allow that action, then that means there's no way I can do it. For instance, using the same scenario that I gave, I want to send an email and my file size is, let's say 300 or just, let's say 100 MB, 100 megabytes. And I know email allows only 25 MB. Any file size bigger than that, if I still want to use email, it won't go through. So that means I have formulated an action, all right, but the system is not allowing that action. So I will still not be able to achieve my goal, or I will not be able to execute whatever action that I want to. Then when we come to the graph of the execution, so user's expectation of changed system state to map to what the actual presentation of this state. So fine, my file size is small. I was expecting to send, or I've loaded the file, click on save. So I was expecting that the file will be sent. And at the end of the day, I should see the actual presentation of this state. So whatever I was expecting to see, I should see it. And so once I see that, then I can say, yes, my objective is achieved. So in doing this, or during this executions, especially with the Norman framework, it's saying that there can be what? Errors, human errors. We have already learned about errors, the slip and then the mistake. So he's saying that the slip and mistakes can happen. That is, the user may understand the goal that he or she to perform. The user may understand the system, that the system can help him or her perform that goal. The user may have correct formulation of actions, but the person or the user may have an incorrect action taken. You may have an incorrect action taken. So I want to send an email. Yes, I know the email system will help me and everything. But I want to send the document as a file and not a link. Now, when I was selecting, maybe incorrectly or mistakenly, I don't want to use mistake because now we are seeing the difference between slip and mistake. I click on a button that I was not supposed to. So at that point, I understand the system, I understand my goal. I have correct formulations to do that, but I incorrectly executed that action. So that means there is a human error in there, there is a slip. And then we also have a state where, that is the mistake, where they may not even have the right goal. So the user may not even have the right goal, or even the actions to take. The user may not have the correct actions to take. So if this happens, how do we resolve that? How do we fix this? So he's saying that for sleep, we need to design a better interface. It could be that I click on something else instead of clicking on the right button, maybe because the two buttons are too close, or the position of some of the buttons are not correct. For instance, I was teaching a web design, web application, then I asked some students to develop a system. And when they developed the system, especially that is a phone, they provided some buttons. Delete, I asked them to provide 4 buttons. So I have insert, I have update, I have delete, and then I think I have select. So those were the 4 buttons that they should add on the form. And I realized some of the students, they've designed the form all right, but right after filling the last input box, that was where they displayed the button, and they brought delete. Somebody brought delete first. So the delete came, then the update, and before the insert. If this happens, you are going to let the people perform a slip, because after filling up to that end, it is easier, or quickly I'll be clicking on the delete button. So the person will end up clearing whatever he or she has inputted. So we need to provide a better design interface to make the system user-friendly for the users, so that even though they have a good intention, they will not end up going through a wrong action. And then when it comes to a mistake, it says for us to be able to fix that, we need to provide a better understanding of the system. We need to let the users understand the system so that they will not make a mistake. All right. Then the second framework that we are looking at is the Abbott and Beal framework. So that is an extension of the Donald Norman's framework. And they have divided interaction into 4 main parts. So they have the user, they have the input, the system, and then the output. Now, what they are saying is, so when we come here, the S for the system, the output, the user who has a task. So meaning the user has a task that he or she wants to perform. Then we have the input. So the user who is having a task needs to make an input. And that input is made into the system. And we say the system is the core. So saying that core means that the system has some functions, or is the system that has to perform its functions to help me achieve whatever outputs that I need, which will accomplish, or which I can say has accomplished my task. So if there is no user, or if there is a user, but the user has no task, then there's not going to be an interaction. As a task, but there is no input. The user did not input those actions into the system. There is no interaction. Now, if the actions are inputted into the system, and the system do not have any functions or the features to perform that, so the interaction will not work, and then process it. Now, if the system received the input, there's functionality, the core functionalities has been performed, but it has not communicated the output. So there has not been a complete interaction. So Abbott and Beal framework is saying that always there should be a user who has a task, and that task should be inputted into where? Into the system. And the system should have some core features that will help the task to be executed. And after the execution, there should be an output. So if you, as a designer, you're designing a form for users to input some data, you have done that. After the user has inputted the data, when I click on submit, I'm just saving. So when I click on submit, give me a feedback that your data has been saved successfully, so that I'll be rest assured that yes, it is true. If it doesn't go through, to give me a message, an error message. Sorry, your data couldn't save. Why? Then tell me the reason. Whether I've done something wrong or it's the system that has an issue. So you communicate that one also back to the user. So Abbott is saying that with the user's intention, is translated into actions that the user will perform at the interface. And those actions are translated into alterations of the system state. So you're understanding the system state now. And that will be reflected in the output display. And so what is the system state? It has saved the record. That is the state of the system. So display it in the output that your record is saved successfully. What is the system state? It couldn't save the data because there was some error. Display it through the output for the user to understand. So the user will receive that display, interpret it, and get to know that, oh, okay, my action has been achieved, my objective has been achieved, or it is not achieved. Do it. All right. So the general framework for understanding interaction is that it's not restricted to electronic computer systems. It identifies all the major components involved in the interaction that we are performing. It should allow, or it allows, comparative assessment of the system. So you compare to see whether your objectives have been achieved, and then it also requires an abstraction. So when we say abstraction, I don't need to know the details of the system. All I need is what the abstract view to tell me that it has gone through. If there is an error, don't give me the entire system error 404, a whole lot of lines of codes, but just tell me that it couldn't save because of maybe I provided an integer value instead of a text, or a text instead of an integer. Or maybe your network was not stable. So just give me an abstract information. Any question up to this point? Okay.
No, please.
No, please.
All right. So we move on. Now we come to ergonomics. Have we ever heard this word? And what does it mean when we say ergonomics? What does it mean if we've ever come across it?
Let me try. I think it has something to do about the functionality of a product.
Okay. Any other opinion?
Madam, please, we are just trying.
Yes, try. Very important.
Okay, so I also think it has to do with how we think, act, and do things and move. Hello. Yeah.
Hello, Sarah.
Hello, madam. Please,
Yes,
did you hear
I
me?
heard you. Yes, I
Okay.
did. I don't know if you want to add more.
No, that's all.
Okay. All right. Okay. All right. Have we ever heard of ergonomics chair? Ergonomics chair. Maybe we have, or maybe we have not. Okay. So what you
Yes.
have said is not far from right. It is not far from right. You are close to right. So we just have to add something small to what you have said. So talking about ergonomics, we said we have the physical aspects, and then we have the industrial the physical aspects of interface, and then you have the industrial interfaces. So now let's look at what an econom is. It is the study of the physical characteristics of interaction. It is the study of physical characteristics of interaction. Then when we come to the point 3, defining standards, guidelines of constraining the way we design certain aspects of system. So economics is simply about you designing a system in a way or follow a better standard, a guideline to design a system in a way that as the human being or as users are using it, they will not have any adverse effects. So you have to consider the environment, you have to consider the system itself, you have to consider the user state, so that as they are using that system, it will not give them any adverse effect. That is, it will not bring them any problem. So I asked whether we know about ergonomics chair. So this is a chair that when you sit on it, it helps you to straighten your spinal cord, your shoulders and all that, so that you will not have spinal problems. All right, so designing systems to aid users so that they will not have any adverse effect. So talking about ergonomics, what are some of the things that we need to consider? So one, about the system itself, the interface, how we arrange items on the interface. If you have developed a system and then most of your icons are tilted on the left side corner of the screen or the window, while the right side, there is nothing there, you are forcing the users to fix their eyes on the left side of the computer. So when they use that system for a longer period, they are going to have a problem with the eyes because their eyes are tilted to one side for a longer period. So the way controls are arranged and then displayed on the screen or on the computer. So example, we have controls can be grouped according to functions or frequency of use or even sequentially. So you need to know the controls that users will be using most often so that you arrange them in that order, or you can just arrange them sequentially, because it's not only about the eyes, the brain also matters. So we don't design a system and then allow users to think too much about what to do next. Because once we are doing that, we are doing what we call the cognitive overload. We are putting too much pressure on their brain. So the person cannot be productive because he or she will always have to be thinking a lot, and that will make the person get tired. So they can't achieve much. So one, the arrangement of controls and displays on the screen. Then you also have to consider the surrounding environment, the environment from which the users will be using your system. Talking about system, certain arrangements and so on. So you have designed a system. I mentioned that this is not only about what? Computers. That's why I'm using systems more than computers or devices. So the first question is, why is the mouse shaped the way it is and it wasn't square, or it wasn't round, or it wasn't even, let's say, triangle, it wasn't pointed? Because of this ergonomics rules, that this is how the human palm is. And the palm has effects on the brain and some other parts of the body. So shape the mouse such that if the user places the arm on it for a longer period, you are not going to develop any other problem. So that is how the why the mouse is shaped in that order. Sitting arrangement. How do we place your computers? You should not sit too close to the windows, that is to direct light. Because already the computer is generating some UV rays, and the light, as the direct sunlight, is also generating some. So when these two rays meet, they refract. So if you are sitting right at the how do you call it, at the window, your screen is pointing to the window, and then you are sitting behind it, you are going to have problems. So the environment matters. Aside that, the way we place or the sizes of objects also counts. And then the third part that we also consider is the health issues. So the physical position, how the user sits behind the PC, they are all part. That's why the last time I mentioned that if we don't take care, in 5 years, 10 years to come, most of our youth are going to develop a spinal problem. Others will also develop mental problems and then eye problems. Because the rate at which we use the screen, and somebody can sit down, bend the head over a phone for about 4 or 5 hours. So the sitting position, the physical position matters. The environmental conditions also matters. You have learned about computers, and then I believe you've learned that computers should not be placed in a place or in a room that is, the temperature is too hot. So we consider all those things, the lighting, the noise. If you have a system and the system is supposed to output information through the audio, then other noises, the feedback noise, other systems in the room should not produce a noise that is louder than the actual noise that the user has to receive. So if you are using a system and the system has to give you a sound, you should not still be playing the audio and all that, which is above or quite equal to the sound of the one that is coming from the system that you are using. Otherwise, you are putting too much pressure on your brain, because the sensor, we've learned about the memory. Your memory has to what? Filter. Now, which one is it going to filter? Is it the one that you are listening to from the system? Because your attention is on that. Meanwhile, there's another music playing around that the system can capture that one as well. So you are putting too much pressure on the brain. And then finally, the use of colors. You don't use a color that when the user opens, there are some sites you go, when you open the site, you have to close your eyes first to adjust your system to the lightning before you can open your eyes back. So you consider also, that is what about economics. Designing a system following standards and guidelines on designing a system such that the prolonged use of that system will not bring any adverse effect to the user. Now we're talking about industrial interface. So we have an office interface, and then we have industrial interface. So when you sit in the office, what do you need? You need some tablets, you need some laptops and all those things. But someone in the industry, I don't know if we have some people who work in the industries. Let's ask whether in the industry, the production field, the construction field, and all those things, those places, is a tablet that you use? No. So whenever we are designing interfaces, we should be mindful of the environment that the interface will be used. Is it industrial or it is an office interface? So we look at some context that matters to each of them. So we said in the office interface, when we're looking at the type of data that are normally used in the office interface is what? Text. But when it comes to industrial, we are looking at numeric. how many cartons of this have we produced? So we'll be looking at, 1,000 this, 200 and all this. So that place, we are much interested in numerical figures than the textual figures or values. Then when it comes to the range of change, how the data changes in the office interface, they say it is slow, but in the industrial interface, it is fast. Because as and when we are producing, our values have to be changing, our data have to be changing. Then the environment setting in the office interface, the environment is clean. So therefore, we know when we are giving direct manipulation, there will not be any effect. But in the industrial interface, in the industries, the environment is dirty. So when you are developing a system for such an environment, you have to consider that the place is dirty, oil soak is here, metals falling here and there. So you know the kind of system that you develop so that you don't have problems. So in all this, we work through what we call the glass interface. That is why all our systems are having glass interface, so that it will prevent the system from being destroyed. So in the industrial interface, so it is always good to be using dials and knobs device. Do we know knobs?
Madam,
My voice audible?
hear you. Please, we are not hearing you.
Hello.
Hello, madam.
So, madam,
Yes.
please, your voice was gone. We were not hearing you.
Oh, sorry. So where did you hear up to?
I think you were about to ask a question also.
Okay. All right. But I think it's stable now.
Yes, please.
Thank you. Okay, so I was saying that in the interface, now when we are designing interface, HCI is telling us that we design interface within what? Glass. So there should be a glass to cover the interface. We will come to paradigms so that you understand when this glass interface started. All right. And then I'm saying that, so in the industrial interface, or when you are designing a system for the industrial interface, it's saying it is better to use dials and knobs rather than using keypads. So keypads are better for the office settings than the industrial setting. So for the industrial setting, we normally use knobs and then dials. All right. Now, we are looking at manipulation, how we manipulate systems. So in the office interface, so we use direct manipulation because you have access to the computer or the device. So through the interface, you have direct access, then you manipulate it. But when it comes to the industries, when it comes to the industries, we don't have direct, so we have indirect manipulation, but we interact through the system. We interact with the system through the, how do you call it, the real world. So you have a big plant mounted there. And with that plant, for you to regulate it, you are using knob switches. We just press, play. You turn it on or turn it off, then it starts working. but you don't directly communicate with the interface, select a menu, select text, do this, do that. No, it's just a knob. It's just a dial. You just do that and then the system starts working. All because of that environment or the environment settings. All right, now the interactions that we do. Let's look at some of the interactions that happens between human being and then the computer. We have about 8 different types of interaction. So the common interaction styles that we have. The first one is the command line interface. I believe we all know when we say command line interface, we know. Those of you who use the Unix server, you'll be writing commands. Those of you who use the Microsoft DOS, if you have ever used that before, DOS, you'll be writing command. For that one, you need to know the language, you need to know the command that you want to write before you can communicate or interact with the device. So you write commands. Then from there, we come to menus, where they give you several options, and then you'll be selecting out of those options. So that is menus. Then we also have the natural language, voice recognition. So you provide or you speak for the system to understand, and the system will also speak to you for you to understand. Then we also have another form that is questions and answers, or the query dialogue. Let's say we are doing an installation. When you are doing an installation of a system, they'll be asking you, do you want to continue? Then you say yes. Click on next if you want to do this. Then you click next. Select a folder. They give you all the folder, the options. Then you check one. So that is the question and answer, and then the query dialogue. So that's also another form of interaction style. Then we have the form fields and spreadsheets. I want to collect data from users. I want the user to provide their information. When we're applying to GCT, I believe most of you bought the form, online form. So you go there, you provide your data. So that one, I am guiding you. I put the label there. Surname, then I give you a box, meaning you are going to type your surname there. Date of birth, I give you a calendar so that you can select your date of birth. Gender, I provide radio button, select one. So that is form filling. That's also another way of interacting with a device or interaction style. Then we have what we call the WIM. That is windows, icons, menus, and pointers. That is the most popularly or the common one that we've been using. Once you open your Windows application, the icons are there for you to select. The menus are there for you to select. The pointer, which is from the mouse. So the mouse gives you the pointer that you can use to be pointing to those options to select. Then we also have the point and click. When we are using web applications, if I want to move from one page to another, there are links there for me to click. So you click on the link, and then it takes you to another place. There is a video there, an audio there that I want to listen. You point, and then you click. You have finished filling your form. There is a button there. You click on the button, then it will perform the actions for you. So that is point and click. And then finally, or not the last, we have the 3-dimensional interfaces, where we try to see the objects as if they are real. So using the augmented realities and then the virtual realities, you feel as if you are part of the system. You wear this VR shades, then you are watching a movie, and then you feel as if you are inside the movie. So these are some common interaction styles. And if you are designing a system, the users, the people who are going to use the system, their capabilities or their abilities and inabilities, their knowledge level, all things help you determine which of these interactive styles that you have to use. So if you are designing a system for our generation, then you go and use a command line. How many people can be writing commands? If you are designing a system for, let's say, children, and then you use menus, how many children can be picking menus? So you always have to get users so that you can the kind of interaction style that suits them. All right, so all this side is about the interaction style. Any question, please? So I've already explained them, so you read through, they've given you the actual data or text over, so under it, so you can read around them. All right. So now we look at interactivity. Interactivity, easy to focus on look. When we are interacting or when we are looking at how to interact with systems, we are much more focusing on what the people can see. That is the look. But what about feel? Do we also consider that when we are designing systems? Do we consider the feel as well, or we are only considering the look? Okay, so no, I think this is also part of the interaction style. That's the speech. So the voice recognition, that's part of the interaction styles. Okay, so let's look at error. Now, in all of these interaction styles, whether you are using the command line, whether you are using the dialogue, whether you are using the form field, or even the voice recognition, we say there can be what? An error. And we also need to repair that errors. So system can't always avoid errors, but we can put them right. Make it easy to detect errors, then the user can repair those errors. So I've designed a system. Let's say we are using form filling, and there is a place that I'm looking for. I need an age. The person should enter the age. So if it is an age, then that means it should be what? Numeric value. If I leave that page, that control to accept text, that means the user can put in a text. And once you are putting in a text for me as your age, it is an error. So I find a way to let the user detect that error and then repair it. So that is why we do what we call the. So if the user enters text instead of a number, you don't even allow the data to be saved into the database. So before the person clicks on the field, needs numeric data. Maybe there is a field which is supposed to be mandatory, information is supposed to be there. Can allow you not selecting your surname, or maybe for whatever form you are filling, your contact number is very necessary. So you have to. If the person that making, take the person back. Left empty. So you let the person help the user to detect the errors and then correct them. So sometimes it is better to let the user avoid the error or help the user to avoid making those mistakes. So if it is a form and I need a numeric value, set that field that it will not even take the test at all. So when the person is typing a text or alphabet, the system will not even take it at all. I have a field, I want the person to enter just one telephone number, and that should be around 10 characters. Then you leave the field empty. Someone can enter about 2 different telephone numbers, giving you 20 characters. Since I need only one telephone number, give a clue. I believe you've done web design. So if you have done web design, you give a clue, what we call the hints, the placeholder. So give the format of telephone number that you want the person to enter. Should it start with +233, that's the country code, or just the number? Keep that format. And aside that, also limit the length of data. I need one telephone number, 10 characters. So limit that page using the maximum length to limit it to 10 characters. So when I enter up to that 10 and I am adding more, it won't go through. If it is age should be maximum of what? 2 characters. Also part 3, that is if the person gets up to 100 years. So this is a system designed for a school. Let's say we are filling admission for. No one in the university can be less than 12 years. For 15 and 16, I think now we are getting because of some situations. But no one can be 12 years. So you make sure that the minimum size or the minimum value and then the maximum value. No one in that university, let's say, should be done. So even if it is mistakenly that the person types something wrong, it will not even take it. And so that is for the errors and then repairs. If there is any question, you can ask. And I believe you can hear me. I believe my network is stable. Okay. And then we're also saying that in everything, for an interaction to happen, there is a context. And so every interaction happens within a context. And interactions are affected by social and organizational context. So like this academic scenario example that I'm giving, you have designed a system for a school. The context is what? That is that school system, that academic system. And so every whatever test that you provide on the interface should be related to the context. If it's a hospital management system that you have developed, your information, your output, everything should be related to that context. So use the terms that they know. That is the organizational context. That organization, how do they refer to their terms? You and I, as lay people, we will say malaria, but in the hospital, do they say malaria? No, malaria is not their term. They use MPs. So they say MPS, they don't use title. So communicate with them in their context so that they can understand the system, and then they don't have to be thinking through what is this, where do I put this? All right. Then we also have to look at what? other people. That is the desire to impress, the competition, the fear of failure. Help us to get our users to use the system. Is it about competition? If let's say a system that you have designed and that system is used for data entry, and you are paid based on the number of entry that you make sure you do the system so flexible that the people can use it as quick as possible. Then motivation, what motivates the users? How will the users be motivated to use the system? Are you creating the system so that already they will be afraid of using the system? Or what? So we consider that. And then inadequate system, cause of frustration, and then lack of what? Motivation. So if the person is not motivated, that one too, they will not use the system. So these are some of the things that we need to consider when we are developing a system. Then we have experience, engagement, and fun. So when we are designing a system, you are designing experience. You are providing physical engagement, and you are making sure you find the physical
Madam,
and not managing. Yes,
madam,
yes.
your line is breaking.
Oh, this. Is it better? Can you hear me
Yes,
now?
yes, madam. When you said is it better,
Yes,
it's clear.
please.
Came clear.
All right, then maybe most often I should be asking, is it better, so that it will be clear. But is it stable now?
Yes, please.
Okay. Okay, so we're talking about user experience, user engagement, and then fun. So when users are using the system, or when we are designing system, you design the system based on the user's experience. And you also need to have in mind the physical engagement, how the user can physically engage with the system. So that means you need to consider their physical ability and also value management. Will they value the system? Is the system going to help them? Will they feel that, oh, for this system, it meets the cost for value? If your system meets these three, then that means the system will be usable, or they will be using it to achieve its usability. So user experience. What are some of the experiences? So about the home, about the entertainment, about the shopping. What is it for? Are you the system for home, entertainment? Is it for shopping? So you need to consider all that. Then the psychology or the psychological experience. The system should balance between anxiety and then boredom. So that people should not be anxious. And it shouldn't also be bored. Then education. So the zone of proximal development, things you can just do to help. So you have to provide the help. You have to provide user guide. You have to provide some voice guide, video guide, so that you always educate the people to make the system easy for them. They should find that proximity to use the system. So all these are some of the things that you need to consider when you are thinking of user experience. Then with the physical design, as we mentioned, one, ergonomics, design the system such that the users will not have any adverse effect. Design the system such that it will meet their physical ability. You are designing a system for someone who is having, or as you are designing a system, you should know that some people may be having a visual impairment, others may be hearing impaired. So design the system that all these people can use it. And what about someone who even doesn't have fingers? So how can that person also use the system? So you consider that as well. Then the legal and then the safety part of it. The legal and then the safety part of it. So when you are designing systems, you need to read about the legal issues concerning such a system. Or within that context, what are some of the legal issues in there? So you consider all this. And then we come to the context and environment. Know the context, know the environment so that you use the language that they understand. And then know the environment. So the process, the way their work, the workflow is. For instance, the hospital management system, we know that the first thing, the person has to be registered. Then now, when I come to the hospital, I start from what? Checking my vitals. From the vitals, now the data should be loaded to the doctor. From the doctor, the data should be transferred. If the person has to go to the lab, the data should move to the lab, to the pharmacy, and so on. So know their processes. And so if you are talking about the environment, not just the physical environment, but the logical environment, the flow of the work, you should know that. Then the aesthetic, the look, the system should look good. It should not put too much stress on the eye or the ear. There are some systems, there is supposed to be a sound. Maybe when I click something, there is some error. The error is given in a form of a sound. But the way this sound, you yourself, your heart will beat. So you consider all that. The colors that you use, that is the look and feel. So the colors should be moderate and all that. Then the economic factor. It should not be too expensive. Neither should it be too cheap. We know in the Africa we did, when the thing is too cheap, then it ends that it is not quality. And when it is too expensive too, you may not get a lot of people to afford. So you consider the economic factor as well. Then we said we have what? Design trade-offs. You cannot achieve everything. And so definitely you need to trade something small for another. So constraints are what? Contradictory. You need trade-off. For example, the front panel and then the rear panel. So let's say we are designing a system that will be very easy for everybody to use. A system that children can use, adults can use, hearing impaired can use, visually impaired can use. Then how do you provide such a system? Meaning you are going to trade off some things, especially the flexibility. You need to bring a little complexity in that system because the user have to do some settings. Go and select this to make it bigger for you. Go and select this to turn the system to a voice for you instead of text and all those things. So you always need to trade something for another. So when it comes to systems, there are always trade-offs. Then we also have what we call the fluidity. So do external physical aspects reflect the logical effects? Do the external physical aspects reflect the logical effect? Whatever the user is seeing. Now, is it the same thing that happens internally? You have designed a system entering data. And so let's say in the data entry, I have selected my date of birth, or I have filled the form. So my surname, first name, other names, date of birth, blah, 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 and so on. Now, logically, when you are writing your logic to save the data to the database and then use it in subsequent pages, the way I save my data, that logic, does it flow in that manner, in that order? We are providing financial values, which are figures. Then I put in 23, let's say 23.50. When you are doing your calculations, does it reflect in that manner? Or you write off the decimal values? So if you are at the interface, you are requesting the user to provide decimal value, then logically in your database, structure the database also to accept those decimal values. So we don't provide a different interface to the user, but logically, the system will be doing something different. So that is also something that we need to consider in designing a system. All right. So these are just some examples of how to provide some of the items. So now, value management. When we are managing values, what do we mean? So that people use something only if it has perceived value. And so before you buy that iPhone something, you have a perceived value that it will help me to do this, do that. And whatever I'm going to achieve, that value is what? Worth more than the money that I'm going to use. You have designed when the users or the organization see it, does it worth what they want to use the system for? A small school, and I need just a system to manage my student record, and you are mentioning 50,000 Ghana cedis. Does it worth it? What can't I use Excel and Word to do that? They will not buy this. So they only use it only if it has a perceived value, and that value exceeds the cost of the system. And then when about the money, but what is it about? It's about the system helping to get the work done. And the work is being done in a nice way, in fun, without any stress. And whether it's also good for others, all the stakeholders, whether they all support it, whether it is good for all of them. And then finally, the download time. How quick, how fast does the system respond? You click on a particular system, 30 seconds, 1 minute, you are still sitting down waiting. No. So the download time, before we even come to the money, the amount of money that we are spending on it, and then the learning effort. How easy is it for the people to learn and use the system? If there is a new staff, if we don't even provide any training, can the person still go ahead and use it? So these are the things that we consider to say that the system has value. So you consider all that as part of your design. All right. Any question up to this point? So in general, what we are saying is that in system design, in ACI, when you are designing a system, you should always be thinking about this. If you want someone to do something, make it easy for them. And before you can make it easy for them, you need to understand their values. Know why they need the system in the first place. Know it. And then develop the system to meet that. Make the system easy such that it can help them achieve what they want. All right. If there is any question, any comment, any contribution, add-ups, additions, and so on, you can bring it on board. Otherwise, we bring the class to an end for today. Any question? All right, is Stephen here?
No question,
Stephen?
madam.
No question.
Okay. Okay, but is Stephen here?
Yes, madam.
Stephen, are we meeting next week?
No, it's a self-study week.
All right, okay. Then I'll be giving my my projects, the topics for individual presentation. The class is small, so we are not doing group. So this one we'll be
Okay.
doing individual. We'll be doing individual.
Okay.
So I'll forward the topics to you. So you let your colleagues have it. That as you are home, you can work around it.
Okay.
All right. So thank you so much. We wish you all the best. Have a wonderful weekend. God willing, we'll meet again in 2 weeks' time. But I will populate the quizzes so that I thought we could finish with the next meeting before we do the quiz. But since we are not meeting next week, I'll populate the quiz. Okay.
Thank you, madam.
So you're welcome. Have a wonderful weekend.
Same to you.
Thank you. You too.
Thank you, madam.
Yeah. Bye-bye.
Bye.